Programming languages are important tools for harnessing the power of computers. Starting from an algorithm that solves a problem, we code the algorithm in a programming language. We compile that code into an executable program. We then debug the program to ensure that it does what we want it to do. Data types are models that guide how we use bits in the computer to represent abstract data. We have data types for numbers, for characters, and for strings of characters, and for logical values. Numbers are, of course, an important category for computers, and we have several different data types: integers and floating point. Let's look at numbers more closely. Here's a number line. We can define unsigned numbers of n bits, in this case n equals 2. They range from 0 to 3. The unsigned numbers don't allow us to represent negative numbers, but they have their uses in certain types of computer arithmetic, like arrays. Here's a signed magnitude number. We use 3 bits instead of 2 to represent these numbers, and they cover the range -3 to 3. 2's complement is another way to represent both positive and negative numbers. In this case, we cover the range -4 to 3. We can do so because 2's complement has only one representation for 0, whereas signed magnitude needs 2 representations for 0. Floating point numbers allow us to cover a much broader range of values at the expense of some precision. We can think about zooming into the number line. Here we've zoomed into the range from 1 to 10, and we can see more detail. Here we've zoomed into a different part of the number line from 0.1 to 1. This number is written in scientific notation, and we can see the different components of a floating point number. There's a significand, a base, in this case 10, and an exponent, in this case 3. A character data type represents a single character in a given language. In this case, we've set C1 to the Roman character small a. A string is a sequence of characters, in this case A, B, C. We'll see that we can further represent strings as arrays of characters. An enumerated type gives names to a set of values, in this case a set of colors. We can correspond these to numbers that we use internally, but it's often much easier to think about these names. Programming languages allow us to declare variables of different data types. In this case, A is of type int, and F is of type float. Scope is an important concept in programming languages. In the C programming language, scope is designated by curly brackets. The outer scope includes the declaration of I and an initial assignment to 0, as well as a printf statement. The inner scope redefines I and has another printf statement. The inner scope redefines I and prints a value. The value printed here will be different than the value printed in the outer scope. The inner scope is followed by another printf statement that exists in the outer scope. The value printed there will be 0 because that is the value of I in this outer scope. Some values in a program are global. They are visible to the entire program. As we've seen, other values can be declared in different scopes that are visible to only a portion of the program. Programming languages use stacks to allocate storage for these variables. Many programming languages also provide a heap for values that don't correspond exactly to a given scope in a program. These heap variables can be allocated and deallocated as needed. The stack in many programming languages grows down. So we start with the scope of function A, we then add the function B, and finally the function C. A stack pointer tells us which function scope is currently active. The heap allows allocation and deallocation of storage that doesn't neatly conform to a scope. In this case, we've allocated a block of memory referred to by iBlock. We then allocate a different block of memory of a different size, referred to as JBlock. We can deallocate iBlock without touching JBlock. Thanks for watching. Thanks for watching.